Hello viewers, in today's session we are going to discuss an important conceptual problem from a domain of functions involving inverse trigonometric functions. So here we have to find out the domain of this function f of x that is equal to square root of sine inverse 2x, right? So this is an easy problem, and here we have to just make use of the range of sine inverse function, right, or the principal value branch of inverse sine function. So let us start. So now from inverse trigonometric functions, we know that sine inverse theta has the range that is from minus pi by 2 to pi by 2, provided this theta belongs to minus 1 to 1. So here we have sine inverse theta greater than or equal to minus pi by 2, and here we have pi by 2, and here we can write theta greater than or equal to minus 1 but less than or equal to 1. So this concept will use while finding out the domain of this function. So here we have square root of sine inverse 2x, right? So the first condition is that under this square root sign we cannot have a negative number. So sine inverse 2x has to be greater than or equal to 0, because if we have a negative number inside this square root sign, then it becomes a complex number, and here we are dealing with only real numbers, right? So sine inverse 2x should be greater than or equal to 0. So now from this inequality, if we take theta is equal to 2x, then this inequality indicates that sine inverse 2x should be greater than or equal to minus pi by 2, and here we have pi by 2, and here we should have this 2x greater than or equal to minus 1 but less than or equal to 1. So now here we have minus pi by 2, and here we have pi by 2, right? And between minus pi by 2 and pi by 2 we have 0. Now see, from this inequality, that is from the range of sine inverse function, this inequality says that sine inverse 2x should be greater than or equal to minus pi by 2 but less than or equal to pi by 2, provided 2x is greater than or equal to minus 1 but less than or equal to 1, right? But here sine inverse 2x should be greater than or equal to 0. So we have to consider sine inverse 2x only in this interval, including 0, right? And all the values of sine inverse 2x which lies in this interval, that is minus pi by 2 to 0, are not allowed, right? So these are not allowed because here sine inverse 2x is negative, that is in this interval which is closed from the left and open from the right. So all the values of sine inverse 2x which lies within this interval are negative, right? But here we have to take sine inverse 2x greater than or equal to 0. So sine inverse 2x should be either 0 or it should be a positive. So we have to discard this interval, that is minus pi by 2 to 0. So all the values of sine inverse 2x lying in this interval should be discarded or not allowed, and we are allowed to take only this interval, that is values of sine inverse 2x which lies in this interval, that is from 0 to pi by 2. So here we have the allowed interval that is 0 to pi by 2. So now we have to write here sine inverse 2x should be greater than or equal to 0 as required by this condition. And because sine inverse 2x cannot go beyond pi by 2, so here we have less than or equal to pi by 2, right? So this inequality is incorporated in this inequality. So sine inverse 2x should be greater than or equal to 0 but less than or equal to pi by 2. So now sine inverse 2x is positive in this interval, that is 0 to pi by 2. So now we have to get the values of x from this inequality. So now taking the sign of all these three quantities, we have sine 0, then here we have sine of sine inverse 2x, and here we have sine pi by 2. So taking the sine function of these three quantities in order to get rid of this sine inverse function. So sine 0 is 0 and sine pi by 2 is equal to 1. So here we have 0, and then we have here simply 2x, because from the properties of inverse trigonometric functions we know that sine of sine inverse theta is equal to theta, and here we have 1. So now we have this inequality 2x greater than or equal to 0 but less than or equal to 1. So now dividing throughout by 2, we have 0 over 2, then we have 2x over 2, here we have half, so this is 0, and here we have x, and here we have half, right? So the domain of this function, that is square root of sine inverse 2x, is given by this interval, that is 0 to half, and it is closed from both the ends, that is 0 and half are also included.